Welcome to my presentation. So this is for Computer Organization Architecture Lab 2. So I am David Chan. I'm in a group with Wong and Rick. So I will represent student 2 to do demonstration for question 2, question 4, and question 6. So let's get started with question 2. Okay, we store X value, Y value, Z value, R value in memory space. Okay, and each value will occupy 8 bytes because they are D-word in type. Okay, so the first line instruction will be move the X value into the register of EAX. So 26, which is 1A, will move into EAX. And second line, negate the value in EAX. So the 26 will be negated into negative 26, and the hexadecimal through 2s complement will be this one. Okay, so the third line, move Y value into EBX. So the Y value will be 30 here, 30, and it will move, which is 1E, will move into EBX. And the fourth line, we subtract what we have in EBX by Z value. So we subtract 30 by 40. 30 minus 40, negative 10. So it will show negative 10 in hexadecimal, this one. FF6. So the fifth line, we add EBX into EAX. Okay, we add negative 10 into negative 26. We got negative 27, negative 36. Okay, negative 36. So the hexadecimal will be FFDC. Okay, then the sixth line, we do an increment to the value in EAX. So the DC will become DD because it add 1. Negative 36 F1 will be negative 35. Okay, the hexadecimal will be here. Okay, and the last line will be we move EAX the value, we assign it into the R value, which is initially 0. Okay, so this 2s complement, the value will be very big if we convert it into decimal. So it's this. Okay, now let us get started with the question 4. Okay, now the data stored will be variable 1, variable 2, variable 4, and the value here. Okay, because they are in a type of word, so each of them occupy 4 bytes. Now we start with the first line. Okay, the first line will be move variable 1 into AX. So the 40, which is 0028, will move into AX. So it's the lower part of the EAX. Okay, then the second line will be move the value of 5 into BX. So this simple. Okay, value of 5, immediate register mode, into EBX. So the lower part of EBX, which is BX, okay, we'll assign it by 5. Okay, then the third line will be multiply BX. 40 times 5 will be 200. Okay, 200 is C8. 200 is C8. So it assigned to the AX. Okay, 00C8. The fourth line, okay, we move the variable 2 to BX. Okay, variable 2, which is 10. The 10 will be moved to BX. Okay, 10, which is 8 in hexadecimal, 0008. Okay, then next line, it will subtract BX by 3. Okay, subtract BX by 3, 10 minus 3 will be 7. So 007, okay, in BX. Okay, next line. Okay, next line only we will divide BX. The 200 will divide 7. So we get 28 and the remainder of 4. In this, we can see 28, 00 on C. And the remainder of 4 will pass into DX. Okay, and the last line, we move AX into variable 4. So the AX will assign into variable 4. So we got 28 in decimal. 28 in decimal. Okay, for question 6, based on the code snippet given in the question, so it's a simple operation which is divide 803 with 10. First we clear DX. Afterward, we load 803 into AX, load 10 into BL. Then we divide AX by BL, called dumrex. Okay, then all the register value will show in exe file built by the system. And the AL will show the quotient, and the AH will show the remainder. Okay, this is what we're trying to do with this code. So, okay, we debug. Okay, all the value in register will show here. We focus on EAX. Okay, the AL will be 80. Then AH will be 03. So 80 as a quotient, 03 as a remainder. We finish our division operation. That's all. Thank you.